Alright, now we are going to look at the second fundamental theorem of calculus. Previously, from the first fundamental theorem of calculus, we have defined that integration of ft dt from a until b is equals to ft. Right, that means you just integrate this and so on. Then f prime t, again when we reverse the process, when we differentiate this capital Ft, we will get back the small ft. We will get back our integrand here. That was from the first principle of calculus. Now we are going to look at the second fundamental theorem of calculus. Again, from the first theorem, uh, we use the limit from a until b. Now we are looking at a little bit different from the first theorem, which is we know that from the first theorem, ft dt from a, which is a constant, until x, we will get fx, right? It's just the same from the above. When you differentiate, when you integrate this, we will get fx because when you integrate the x terms, it will leave your answer in terms of x. And then when you differentiate fx, and then that means you have to differentiate all the function here. So when you differentiate this, you will get f prime x. So what is our f prime x? Previously, we know that f prime t is equals to small letter ft, and now capital F prime x is equals to f x. Okay, let me give you an example. So you want to differentiate this by using the second fundamental theorem of calculus, we will get fx. So what is our ft here? Identify what is our ft here. It is t cubed. So if ft is equals to t cubed, then fx is equals to x cubed. So that means when you differentiate this, you will get x cubed. Okay, that is what the second fundamental theorem of calculus is. Alright, another way, if you forgot the theorem, you can do it manually one by one, which is first you have to integrate t cubed here respect to t, and then when you get the answer in x term and then you differentiate it, again you will get x cubed. Okay, let me show you how. Okay, first let's do it together. Let me just copy this. I've just copied this without the answer. Okay, now let's do one by one, which is we integrate this function here first. When you integrate t cubed with respect to t, you know we will get, by using the first fundamental theorem of calculus, we will get t to the power of 4 over 4 from 1 until x. And then substitute the limit, and we will get x to the power of 4 over 4 minus 1 over 4. Now, when you differentiate this, you will get 4x cubed over 4. When you differentiate a constant, you will get 0, which is minus 0. And this is equals to x cubed. See, as I told you earlier, we will get again the same answer by using the second fundamental theorem of calculus. Alright, now let's look at one more example. I'm going to show you. Let's look at this example. So you want to differentiate this and integration of this by using the second fundamental theorem of calculus. Alright, first you have to identify what is our ft. So our ft is sine t over t. This is our ft. So when you differentiate this integration, we will get fx. So what is our fx? It's actually sine x over x. We just substitute t here into x. So that means integration of this, we will get sine x over x.